Okay, let's put in T's. So T here. And then we're going to go for 30G downwards. And then we go for 40G going straight down, which would be the weight of the particle P. But then there's obviously components at play. So this is 40G. This would be 40G sine 30. So 40G sine 30 is a 20 root 3G. Is that it? Oh, sorry, it's a half, isn't it? So 20G, my fault. G, and then the other one is 20 root 3 because it's cos. Right? Then go up the top here and get the R values. What's the R value? The reaction force has to be equal to what? The 20 root 3. They're balanced because it's not sinking into the surface, okay? And then following that, what we have then is, we have to get friction, don't we? What's friction going to be? A quarter of your 20 root 3 G. What will that be? 5 root 3 G. Going to the left, okay? Next thing we're going to look at is the T values. Because there's tension in every aspect of the string, that means T going this way and T going this way. And that's why we have 2T pulling up the hill. The next decision you have to make is, do you think the 30 kilograms is going down or up? Or does it even matter? What happens if you're wrong and you guess the wrong way? Get a minus. So it's actually irrelevant, right? Now to me, because it's only battling 20G, see the way the 20G is pulling against the rope? To me, that means the 30G wins. Okay? So I'm going to have the acceleration going this way. A common acceleration. Oh, no, here's the next one. There's a catch here as well. Anybody know the catch? I'm going to check with the market scheme before I fully commit. But what's the catch? For argument's sake, let's see this in yellow. For every 20 centimeters of rope it bends, how much does that one have to, how much would this one move? It'd lose 10 centimeters from here and 10 centimeters from there. Does everybody see that? That to me implies it has half the acceleration. Would that make sense? Now, obviously, when you're... So guys, we are correct. It's a half A and A. But if you want to avoid fractions, you could call this one A because its acceleration is half that of the other particle. So you could go for A and 2A. Does that make sense? Good. All right, let's continue. All right, let's start off with the easy money. Which one's the easy marks? 30G is the easy marks. Okay. What way is it going? Downwards. So force equals its tension minus its weight for the win. And what we get is 30 times 2A, yeah? I just want to make sure I'm definitely right with this. It's 30 kilograms and 40 kilograms respectively, right? So 30 times what? 2A equals, and T is just T, and that's 30G. And now we have 60A equals T minus 30G. Always get your marks on the board, okay? Now, next thing we're going to do is we're going to go for the particle P. Once again, F equals... Oh, guys. Huge mistake there. Anybody see it? Who's winning, weight or tension going downwards? Weight's bigger than tension. Sorry, so it's force is going downwards, weight minus tension. Because weight is dragging it downwards, that has to be the opposite way around. So 30g minus t. Once again, taking time to reflect on your formula, saving you a lot of time and marks later on. Everybody okay with that? They're always the opposite of each other as well. That's how I actually discovered that mistake. Let's say you do weight first on one of them and tension seconds. The other equation has to be tension first and weight second. That's how I knew I made a mistake. I knew it because it's always the opposite of each other. And I was about to do the same thing twice, and I knew, wait a minute, made a mistake. So just remember that. They're always the opposite of each other for the most part. When there's two of them, they're always the opposite of each other. So this time it's tension, take away, weight. 2 times the tension, moving it diagonally upwards. Anything else move it diagonally upwards? No. Anything move it diagonally downwards? 20g. Anything else move it diagonally downwards? 5 root 3 g. What can I change the f into? What? 48, exactly, yeah. Now, I think what I'm going to do here is I'm going to multiply friction opposes your motion. So if you're going up the hill, the friction opposes you down the hill. If you're traveling down the hill, friction opposes you up the hill. Alright, what I'm going to do is I'm going to multiply this yellow equation here by 2. I'm hoping I can add on to both sides then. So I think I'm going to get 120a equals 60g minus 2t. These are going on a height, so I'm going to get 160a equals 40g minus 5 or 3g. Then it doesn't really say how to do the answer, but I suppose we'll just do 40 minus 5 root 3 and then divide all that by 160. And we get 8 minus root 3 over 32. So a equals 8 minus root 3 over 32. G. I always tend to put in the decimals as well. Double up. 1.9196. 9196 m squared. Alright. I also have to find the acceleration of q, don't I? Oh, that's easy. You just double it, don't you? Double the answer. So what's the acceleration of q then? 2a would therefore be 8 minus root 3 divided by 16g. This is the acceleration of q, acceleration of p. Alright? And if we double it, actually I'll just double the rounded off version. 3.8392. Okay, what does it want from us next? The speed of p when it has moved 30 centimeters. 30 centimeters is 0.3 of a meter. So we're going to go for u vast. S is 0.3. Which one's p again? The one with acceleration a. So 1.9196. U is 0. Phi squared equals u squared plus 2as. Go with that? Alright. What do we get then? Phi squared equals 0 squared plus 2 times 1.196 multiplied by s. Multiply that out and square root it. We're good to go. Square root the answer. 1.07. Okay, all good.